Dear students, today we are going to start new topic, that is electromagnetic induction. Let us start with magnetic flux. What is magnetic flux? If we consider a plane perpendicular to a uniform magnetic field, then the product of the magnitude of the field and the area of the plane is called the magnetic flux phi linked with that plane. Figure shows a plane of area A placed perpendicular to a uniform magnetic field B. The magnetic flux linked with this plane is given by phi equal to BA. If the magnetic field B, instead of being perpendicular to the plane, makes an angle theta with the perpendicular to the plane as in figure, then the magnetic flux linked with the plane will be equal to the product of the component of the magnetic field perpendicular to the plane and the area of the plane. Thus phi equal to B cos theta A from figure B equal to BA cos theta. Phi is positive if the outward normal to the plane is in the same direction as B. It is negative if the outward normal is opposite to B vector. The SI unit of magnetic flux phi is Weber WB. Since B equal to phi upon A, the magnetic field is also expressed in Weber upon meter square. That's why the magnetic field induction B is also called the magnetic flux density. The CGS unit of phi is Maxwell, where 1 Weber equal to 10 power 8 Maxwell. Magnetic flux phi is a scalar quantity, while magnetic flux density B is a vector quantity. Dimensions of F, dimensions of phi equal to BA. From the formula F equal to BIL, force on a current carrying conductor in a magnetic field, we have B equal to F upon IL, thus phi equal to FA upon IL. Therefore phi equal to MLT minus 2 L2 upon AL equal to ML2 T minus 2 A minus 1. Magnetic flux may also be expressed in terms of the magnetic lines of force. One can represent a magnetic field by magnetic lines of force. If we draw limited lines of force so that in a magnetic field B equal to 1 Weber upon meter square, only one line of force passes per meter square through an area perpendicular to B. In a field B equal to 2 Weber upon meter square, only two lines of force pass per meter square perpendicular to B, and so on. Then these lines are called the lines of flux. In a magnetic field, the number of lines of flux passing per meter square through an area perpendicular to the field is equal to the magnetic flux linked with that plane. If a plane is parallel to the magnetic field, then no flux line will pass through it and the magnetic flux linked with that plane will be zero.